And as usual, after studying what the functions are, we should discuss the limit at a point and then the continuity. After continuity, you should study the derivative and its application. And after derivative, you study integrand, but integrand involving several variables. So this picture is quite usual for calculus, one variable and several variables as well. So now the first, we remind the set Rn. The set Rn consists of all n tuple. N tuple mean each tuple consists of n entry. We call coordinate, and all entries are real numbers. For n tuple in Rn, we can, so what here, let's see, I remove that one. We can have two operations, addition and scalar multiplication. So addition and scalar multiplication, both operations are coordinate wise. That is, when you add two n tuple, you must work on coordinate, corresponding coordinate. And when you multiply the n tuple by a number, real number, you multiply each coordinate. So from the point of view of linear algebra, you study last semester, Professor Dung taught you, right? This set Rn, together with two operations, addition and scalar multiplication, form the so-called vector space, R vector space, or vector space over the field R, the real, right? So that is vector space, okay? For three particular case of n equal to 1, n equal to 2, and n equal to 3, they are more specific for us. And when you have n equal to 1, instead of R1, you write R, the usual real line. But in case n equal to 2, R2 is two-dimensional plane. So again, from the point of view of linear algebra, you have the basic and dimension. When the vector space is of finite dimension, you have only one number for the dimension, but you have many bases, right? Different bases. And you can have standard basis, so that you have to revise your linear algebra last semester. But R2 is two-dimensional plane, which means that two-dimensional vector space. And instead of x1 and x2, because we use x1, x2, and xn, right? Instead of x1 and x2 for a point in R2, in this case, we use x and y, which means we have x-axis and y-axis, the two vector of a basis, the standard basis for R2 are on x-axis and y-axis. Similarly, for the case n equal to 3, R3 is three-dimensional space we live in. So we are living in three-dimensional space, right? And again, we don't write x1, x2, x3, but instead we write x, y, z. That is, we have x, y, and z axis for indicating a point in R3. Okay? So first, talking about R2, which means the xy plane, you understand that you have two perpendicular axes called x-axis and y-axis, and they intersect at 0. 0 is called the origin of the xy plane, right? And of course, you understand that every point on xy plane is characterized by two coordinates, A and B. A is real number on x-axis, B is real number on y-axis, right? So that's all the thing you know. And usually, we should understand that if you are given R2, then it means you are given the xy plane, as I already presented on the slide. Okay, so in general, you know quite well the coordinate geometry from your high school. You have a point, for example, 2, 1 or negative 3, 2 related to the x and y, right? That two coordinates. So it is very clear. But more interesting is you should remind the equation of some very important straight line and curve in R2. So for the equation of a line, you have this one, and don't forget to provide the condition a squared plus b squared is not 0, which means at least one of the two coefficients a and b must be non-zero. Because if it is 0, then it means both a and b are 0. Both a and b are 0, the meaningless in the sense that if c is non-zero, you don't have any point. If c is 0, you have every point of the plane and nothing to work on that, right? Okay. And equation of a circle, you also should remember. So here, the circle centered at a point AB of radius R. So pay attention, we write R square. It is the same as negative R square. This is the same, right? But when writing this, you should understand that R is positive, which is the radius of the circle. More complicated is equation of ellipse. Usually, you have x squared over a square plus y squared over b squared is 1, right? With the foci AB, but actually in general, you have this equation and you can make a translation or change of variable. So for example, this is x square, x prime square. This is y prime square, and then you can change to the standard equation. So this equation of an ellipse with centers at a point A and B, right? Again, R is positive. That are two. Quite similar to the case you have three variables R3. This is three mutual. You see, you should use the mutual, which means that every two axes are perpendicular. Every two. You should have three pair of the axes, right? Again, intersection is called the origin. This is 0. And every point is characterized by 3 coordinates. And again, if you are given R2, R3, you should understand that you have your X, Y, Z space in your hand. For this R3, you please remember that you have 3 coordinates. The first 2, when you project it to the X, Y plane, right? Then you have X is 2 and Y is 1. X is 2 and Y is 1. For Z, you should project it to the Z-axis. Then you get 3 coordinates. And for that R3, to understand, to recognize, to determine the positive direction, at least for Z. So here you see you have positive and the other direction is negative. How to determine? You use the so-called right-hand rule. Right-hand rule in physics related to the force you want to determine. But right-hand rule in mathematics is to determine the positive direction of, for example, z-axis. So you type on internet the right-hand rule for mathematics, or in mathematics, you understand what it is and how to use it. That using 3 finger of your right hand. Okay. Similarly, for R2, you have the equation in R3, and in this case, no more straight line. Equation in R3 must be plane, and you also have 3 coordinates, not on 0. And you know from your high school course that if you take the coefficient of x, y, z as ABC, you have a normal vector. A normal vector is, this vector is perpendicular to the plane. So if you have this plane P, right? Then the normal plane here is characterized by 3 coordinates as coefficient of the equation. That pay attention. And from that, you can see if you use the vector form, you can have the r minus some fixed r0 is on the plane and is normal vector. Then because they are perpendicular, the scalar product of these 2 vectors in R3 is 0. So that's the vector form of a plane. If in R2, you have the circle, right? You have the circle centered at AB, for example, and radius R. This is circle. You have only 2. Then in the R3, you have the so-called sphere. Only sphere, not inside. This on, this boundary. Because if you talk about inside, here, inside, including inside, you have a disk. You have a disk. But if you look at inside also, so then you have less than or equal to R2, right? Then you have a ball. That. But here you have only the boundary if it is circle or sphere. equal only on the sphere, right? And centered at ABC point, the center and radius are again. So that's the case. X squared plus y squared plus z squared equal to 1 is a purple. Yellow is 4 and blue is 9, right? Corresponding to radius 1, 2, and 3. For ellipse, you have ellipse in R2, right? That one. And now you can have the so-called ellipsoid. Ellipsoid means you have the form of ellipsoid, but in R3. And actually, in our life, you may have a lot of things with such the shape. So for example, you see what you look at the camera. See, if when you go to the watch shop, right, you can see you have they always give the form of the watch like that. So this form actually present the ellipsoid, right? When you go to the watch shop, you always have such a thing. So it's quite normal in our life. This very many things you can have the shape of the ellipsoid. Now, after having in your hand R2 XY plane or R3 XYZ plane, we start to have a definition of function of two variables. For function of one variable, you understand that if you have a function fx, then domain of definition is a subset of the real line R, right? And usually if you have x here, some part, for example, D here, then you have under the mapping F, this is somewhere in this case. That's the function. And every point x from the domain, you can have the unique value fx. Yeah. Exactly, we do the same for function of two variables. If we have a function of two variables, it means that first you should have a domain of this function, which means f can be evaluated at this point, or we write f as xy, where xy belong to R2, right? And function means you have in your hand a rule. In Vietnamese, we say, với mỗi một điểm xy thuộc D thì cho ta một cái giá trị duy nhất. Và ký hiệu là fxy. Nhưng mà với tiếng Việt, với mỗi thì chúng ta phải hiểu là cách dùng trong tiếng Anh. Exactly as one variable, to each point, we assign a unique real number. So to each point, we assign a new unique real number. So it means when you look at the picture, right? When you look at the picture, so it erases not easy with that one. Let's see whether I can use this eraser or not. The same, not better. Okay. So then I try to erase first, and it takes a bit of time. Haha. Not like annotator in Windows. So here I use Mac. So, okay, more or less what we have. We have any point on D, any point x, y on D in R2, to each x, y, you have a point f, x, y in R. This is destination. You cannot have this situation. Cannot. Because to each x, y, we assign only one unique number, right? You cannot have this the other case. But it can be happen that you have another x prime, y prime, and also assign the same value of x and y. No problem. We say unique real number assigned to a point x, y. We don't say that to only one point, right? Okay. So for example, if you look at the function, this one represented this one, then you have x is plus minus 1, y is plus minus 1. You have even 4 points. The unique real numbers assigned to even 4 points of D, right? So that's the thing you should remember, okay? So usually we write more explicit z equal to fxy to understand that for each point xy, f is evaluated at this point and give the value z. Okay. In this case, you see x and y are independent, which means that freely run over the domain D. But for each x and y, substitute to the formula of f, you get the value of z, which means that z is dependent variable. Value z depend on what x and y are. Okay. So, and here you should have a note. When the domain D of f is not specified, what to do? Then you should take D as the largest subset of R2 on which f is when defined at this point of every point of R2. Then you have the domain. Okay. Now we will look at the different example on that one. More than that, here I write many functions depend on more than one independent variable. So, which means you may have more than one independent variable. Independent, which means you have more than one variable. So here, I mean in the real life, you may have the situation that one quantity depends on two or more other quantity, which means that you have more than one independent variable in your real life. So for example here, when you consider an electric circuit, usually what you have? You have resistance, measured by ohm. You have current I, measured by ampere. And you have power, measured by watt, right? So this quite usual electric circuit. And we will return to this thing in the second part of the course, ordinary differential equation. You will have something related to that. Okay. And between power, resistance, and current, you have the relationship by the equation P is RI squared. So from this point of view, mathematically, we can think that P is a function of two variables R and I. That one. See? So this is electric circuit. You have a function of two variables, resistance and current. Right? So in geometry of mathematics, you can think about a distance function. So here on R2, you are given a point Q. This is a fixed point. Q, this one. Q, coordinate A and B. And any point P with coordinate X and Y on the plane, you can measure the distance D of XY from P to a fixed point QAB. And D of XY is computed by this Pythagorean formula, distance, square root of x minus a square plus y minus b square. So it means a distance from a point on the plane to a fixed point Q is a function of two variables x and y. That again, and domain in this case, you see, it is not written. What's the domain of this? So domain of this means on x and y point at which you can compute the distance to Q. So what is that? Every point on R2. So which means the domain of this function is whole R2. Okay. Next example. You are asked to find and sketch the domain of this function, and then evaluate it at a point x is 1 and y is 2. The first one, domain of x and y means that you should look at all points x and y for which the formula fxy is when defined. When defined means that the formula of f is when defined. So here you have y minus x square root at numerator and x minus 2 at denominator. The first thing, denominator must be non-zero. The second thing, square root is taken for only non-negative number. So you should have this one. And combining both, you have on point at which f is when defined. So that is, you have x square is less than or equal to y and x different from 2, right? So that one. And evaluate it at a point x equal to 1, y equal to 2, you get these things. So how about the sketch of the domain of F? This is more interesting. So you should understand that a domain of F consisting of two conditions. First, easy condition, x different from 2. So you should not have x equal to 2. And the second, y bigger than or equal to x squared. So x squared here, that x is 2, then this is 4. Right? 1. So x bigger than or equal to y equal bigger than or equal to x squared. How to find? You take any point on the plane and see whether it is okay or not. If this okay, all so the parabola divided the plane into two parts. One part you have bigger than or equal, or bigger than, you don't talk on the parabola. One part is bigger x squared, the other part on point is less than x squared. So for example, you take the point x is 0, y is 2. That is, you consider 0, 2. This is x is 0, y is 2. You have this one, right? X is 0, y is 2 here. Which mean you have this part all containing, including the boundary x, y bigger than or equal to x squared, because it contains 0 and 2, and remove that part. So then you get the domain of F. Okay, so very interesting. That's why I write this is important. You should sketch the domain of a function. Okay, now talking about graph, you should pay attention. For n equal to 1, you have a function fx, right? And fx, where? Fx is on the real line. This is f of x. But if you want to have a graph, you should have f equal to y equal to fx. And it means that the graph is on xy point on R2, for which fx equal to fx y equal to x squared, which means you already have in R2 one dimension more, right? So in this case, for example, y equal to x squared, you have this graph. Graph already in R2 because you need two coordinates. The same thing for two variable function, which means x and y in R2. For graph, you need in R3, 3 dimension. 1 dimension up. That is graph of a function of two variables z equal to fxy consists of all point xyz from R3, for which fxy is equal to z for any xy from D. So graph is in one more dimension space. Okay. So, and it's very challenging to sketch on a paper because our paper is R2. This is in R3. And how to sketch it? That's very interesting. For example, here, this is domain of F, X and Y. But F, X, and Y somewhere there. See? And when X and Y run over the domain D on XY plane, then you have graph somewhere in the space. Somewhere in the space, right? And not a plane. This is not a plane, but depending on the value of F, it is a solid. It means that the set in R3 already. Okay. So next, for two variable function, we may consider the own point where F has the same value, which means that Fxy is K. K is a constant. And this set of this point is called level curve because it forms a curve on R2. Because here in R2, right? So level curve. That one. Here, a graph of a function f equal to fxy. But when you look at own point from R2, value is the same, which means that the height, for example, this one, the same k. This is the same k. Own point here have the same amplitude. That is, if you look at this part, x and y, f, x and y, on here, sorry, not inside, out on that boundary, own point have the same k, amplitude, độ cao là bằng k. Nghĩa là gì? So this means it is this perform the level set, mean that you have own f have the same k, right? So more than that, from this, if we think fxy as amplitude function, tức là cái độ cao đấy, then level curve give you a contour map. And it is very interesting and important in geography. And you can see it reflected on the map. Cái bản đồ là bao giờ cũng có được cái liên quan đến contour map, bởi vì bản đồ là R2 ở trên mặt giấy. Nhưng mà kem nhìn, kem hiểu được đấy là cái độ cao của từng vùng một ở trong không gian, tức là trong đất nước mình, ví dụ vậy. For example, here you see. Actually, if you look from the space, you have this one or that one. But it reflects on the map here. For example, it is in Mù Căng Chải. Somewhere in Hà Giang, chúng ta có thể đến đấy mà chụp ảnh. Thì các em thấy núi đồi rất là nhiều. Thì cái quả núi này, người ta hiểu đấy là quả núi, nó rất là cao, độ dốc rất là dốc, con này ít dốc hơn. Nhưng mà trên bản đồ thì nó phải ra cái hình này. Bản đồ là hình đôi mà, là R2 mà. Thì như vậy là gì? Chúng ta hiểu rằng cái đường này là liên quan đến cái vòng này. Đấy. Thế còn càng lên cao thì nó càng lên đỉnh của nó, đây tít trên đỉnh. Đấy, nếu mà ta nhìn cái contour map là như vậy. Và các em hiểu như vậy là rõ ràng rằng giữa cái R3 với lại cái R2 nó related bởi cái contour map như vậy. Đấy, ta nhìn vào cái này thì rõ ràng là gì, đấy là bản đồ mà. Nhưng mà ta vẫn hiểu được chỗ nào là cao, chỗ nào là thấp, bởi vì theo cái tính chất của cái cách xây dựng cái bản đồ. Đấy, cái contour map nó liên quan đến như vậy. Ok. For example, if you are given this one, a function, how about the level curve? Curve đây tức là một cái đường cong, tức là đã nói đến level curve có nghĩa rằng là tất cả các x y ở trên mặt phẳng sao cho cái này là bằng 75, mà có nghĩa rằng nghĩa là nó tạo thành tất cả cái điểm này tạo thành một cái đường cong, cho nên người ta gọi là level curve, tức là đường mức. Đó. How to do? Solve it. You solve on point x, y from the level curve give you the 75. So you have this one. Solve this and you get that one. What is this? This is a circle centered at 0 radius 5. That is on point. Satisfy this condition on point on the circle. This circle form the level curve corresponding to k equal to 75. And if you ask passing this, which means that substitute x equal to 10, y equal to 0, you get the level curve must be 10 square, 100, right? So, which means the level curve now is circle centered at 0 and radius 10. Okay, so graph and level curve of that. Of course, level curve here, R2, this is R2. But graph in R3, that's why you have this one. This is already like a bell, right? Giống như quả chuông rồi. This is graph. But level curve here. Level curve here, level curve. But that's all the green give you the graph. Okay? So that we stop at this point for the first hour, and now we take about 10 minutes, 10-15 minutes, and we continue the second part thereafter. Okay, so a short break. Short break, you have. Okay, short break, short break. So we continue. Thus, we finish the function of two variables, and now we do almost the same for the function of three variables. Again, in this case, you have a domain in R3, and exactly the same as function of one variable or two variable. The function of three variable means it is a rule to each, again, two, right? To each point in D, we assign a unique real number and denoted by f, x, y, z, okay? And for that case, because we already use x, y, and z, now we write w is f of x, y, z to make it explicitly, okay? So, and surely now we understand that we have three variable independent, while w is dependent. It depends on what x, y, and z are. So how about the level? The level set in this case is a set of all points, exactly the same as a function of two variables where f, x, y, z is a constant k. So, but the thing is, if for f of two variables, we call this a level curve because this xy in R2 forming a curve. Then for three variables, we call a level surface because it is on point x, y, z in R3 and they form a surface in R3. So the name is curve and surface. Okay, here, for example, you know, we already talked about that. Actually, here, the purple color on point x, y, z for which f, x, y, z equal to 1. K is 1. So this is the sphere centered at 0, radius 1. Yellow on point x, y, z for which f, x, y, z is 4, which means you have yellow surface, which is a sphere centered at 0 of radius 2, etc. Okay, so similarly, you may be asked to find for the function x minus y squared plus y squared plus z squared the level surface corresponding to that one. So this is K. And of course, you solve it. You get this mean 1, 0, 0 center, a sphere. Radius square root of 9 is 3. And again, if the level surface you have to find passing this point, means that this point satisfies the condition. This is some K, right? So you computed it, you have 13. F, so 13 means that all level surface, including this point, have the same constant 13. So it is again sphere centered as 1, 0, 0 and radius square root of 13. So it's very simple. Okay. So and n equal to 2 you call a level curve because in R2. N equal to 3, you call a level surface because it is in R3. So if N equal or bigger than 4, you have the thing that F first N variable domain exactly the same. Okay, this is the same domain and definition of a function. But for level curve or space, in the case you have to find own point x1, x2, xn at which f is a constant, and it called no more curve, no more surface, because no more in R2 or R3, it called a level set. So remember that, okay? Level set for the case n is bigger than or equal to 4, okay? So, and of course, we now can use any letters, even Y, Z, but it better not to use Y and Z. We use W because Y and Z make you confusing when n equal to 2 or n equal to 3. So for any n, we write W is f x1, x2, xn. And as you already noticed, when I say f is evaluated at a point x1, x2, xn, means that you compute this value, and the value W is called evaluation of f at that point, right? So of course, you have x1, x2, xn are independent variable, while W is dependent variable. Okay? That evaluation and evaluated. Okay? And now we move to the next part, limit. So talking about limit, remember intuitively, you have a concept of limit for a function of one variable. When we want to talk about the limit of a function f when x tends to a is L. So that one. What does it mean? X tends to a point A means that x get very near to A. Then f tend to L means that f is very near to L. How to understand very near? So very near means that a distance between x and A, and also distance between fx and L. But talking about distance, you have the absolute value of the difference between x and A, and here this is absolute value between Lx and L. So this very near, which means that is very close to 0. Then this also very near means that very close to 0, right? So in this case, here I already explained what I talked to you, just talked to you. The distance very small, and the other distance also very small, right? So from that, we have the definition, formal definition for one variable limit. What is that? If a function you study in calculus 1 is a function of one variable with a domain D and A is a point in R, not necessary in D. So for example, do you remember if we talk about the limit sine x over x when x tends to 0, 0 is not in the domain of this function, but we can consider the limit as x approaching to 0, because you know that it exists and equal to 1, right? But not necessary in the limit. Then we say that fx has the limits L as x tends to A. If, so now you see, this is x, this is fx, this is L, and this is A. What's the meaning? For any neighborhood, you take this the first step. First step, any neighborhood with the radius epsilon of L taken, then you can find the corresponding delta neighborhood of A. You can find any epsilon positive, you can find delta positive, such that any point here together with D, which means that must be in the domain, so intersected with D, and maybe excluded point A, no need point A, right? A maybe not in D. Then all point from this neighborhood intersected with D are mapped under F to this epsilon. So, and actually this is illustration, but the main thing is here. You should understand the intuitive things, and we transfer this idea to several variables. For two variables, again, intuitive concept means we say limit of fxy is L as xy tend to A, means that fxy is very near to L when xy is very near to AB, right? But very near in any possible way, which means here, if we talk about the neighborhood of L, then fx should be inside the disk epsilon, here epsilon, okay? That epsilon, here epsilon, oh, epsilon here, right? So if x in delta neighborhood, of course intersected with D, I suppose, any x here is mapped in this one under F. So this is, but x very near to A, and you see in any possible way, which means that x can approach A like this, x can approach Y like that, like this. So anyway, each tend to A. You don't know which way, but you are sure that anyway, you should have again the image of x under F very near L in such a thing. So how about near? Distant. How about distant? In R2, that, yeah, This is distance. If I denoted this by Q, by P, number this point P, and that XY by M for moving, M stand for moving, and P here a point, a fixed point. Then XY is near AB. We can understand that for any M is near a fixed point P. That is, this is the distance from M to P. You can compute it like that. This distance less than delta, then the image less than epsilon. So that's why we have a definition. We have a definition. A function of two variables, domain D in R2, and you have a point P is not necessary in D. We say that limit of f as xy, because any point on R2 is characterized by two coordinates xy tending to AB. That is M tend to P. Is L, limit is N, if any neighborhood of N is given, you can have neighborhood excluded the point AB, the point P. Delta neighborhood together with the condition must be in D, all are mapped to the neighborhood L of epsilon, which means here a disk, this disk is mapped to that disk. Okay, so this is the mathematical definition of the limit. So from the limit, the formal limit, you can have a lot of consequences. The first thing, if limit exists, then it is unique. That is, you cannot have the situation xy tending to AB. One student say L1, the other student say L2, and they are different. Then either one of these two students is wrong or both are wrong. Cannot be the case both are true. No, right? Because the unique limit, if exists, then it is unique. You also have algebra of the limit. We talk about this a bit later. And you have very easy to prove that proposition 2 give you the integer non-negative. If a function fxy depend on x only or depend on y only, then consider the point xy tending to AB. For the first case, you don't have to care about B. No y. You look at only x tend to A, then the answer is A to power n. The same for the case x is not involved. Don't have to care about x tend to A, any x. But y tend to B, then you have B to power n. So remember, talking about xn and yn as a function of two variables, you must pay attention on the fact that it can happen some variables are missing, are not involved. It doesn't matter. Also, it doesn't matter, right? Also, when you have the function without some variable, it doesn't matter. You still have a function of all variable you are given. Right? You should understand that you have function of two variables. In the case, even either x or y is missing. Okay. So, and now we come back to limit of this algebra of limit. Again, as the calculus one, the first thing you need is existence of the two limit. Must exist first. Then you can see alpha f plus beta g equal to limit of this sum is sum of the limit. And you can take out alpha and beta. So what is that? This is linearity. You study in linear algebra like transformation, right? Because when alpha and beta are 1, you have addition, right? Limit f plus g is limit of f plus limit of g. In the case, alpha and beta are equal to 1. But in the case beta equal to 0, you have a scalar multiplication. Because in this case, limit alpha f is alpha limit of f. But more than that, you can consider the case alpha is 1, beta is negative 1. Then you have f minus g, which means that the difference. So this is linearity of the limit, right? But more than that, you still have product of the limit is limit of product and limit of quotient is quotient of the limit, provided the limit in denominator is 0. Okay, so such a thing you need, and using that you can have other result for the limit exactly as we did for calculus 1. Okay, example here, very easy to apply. First, remember you should have the limit of a point x, y as it tend to a point or approaching to a point, fixed point A, B. And here you have the sum. You can take the sum of the limit, which is a square and b square, using proposition 2 we talked about, using this proposition. Okay. That. Similarly, for the second, you have product, and then you take product of the limit, because each limit exists. Very important. Each limit exists. Then you can have the product of the limit and get the answer. Okay. So before talking about the next limit, I want to remind you the following. This what I already mentioned. Yeah. Yeah. See? That one. X get very near to AB in any possible way. Which means that when you look at this x, y tending to point AB here, you understand that you can consider let x tending like this. You can let x tending like that. Or you can let x tending like this. It's up to you. But in any way, you let x, y approach AB anyway, you always have this situation. Image of all x on each way always are in this. So regardless in what manner x, y approach AB, the same result. But if you think you have three ways, you can think about C1, this straight line, this zigzag, this curve, you call C2, and this zigzag, you call C3. So which means you have three ways. You provided on this line, three ways of approaching XY to AB. Of course, you can have other way. And how many ways you can have? Infinitely many ways. You cannot count it. Only approach AB, where XY exists this. A lot of way, right? So, but for each way, you can give the name. Then it leads you to a new definition of a limit, which called limit along path. Limit along path. So suppose you have a path passing through AB. So, okay, AB here. And you have this path. That one. This is, we call C, right? Suppose you have that. So then you consider value of fxy as x tend to AB along a path C. You consider each time xy on C. So which means that xy belong to C, right? Belong to C. And if you want to have this value, and you can look at the limit of that. Limit xy tend to AB, but on the path or along the path C. And if limit exists, then we say that fx has a limit along a path C as xy tend to AB, right? So, for example, your f here. So, fxy is x squared minus y squared over x squared plus y squared. So how about approaching? First, approaching to the origin, right? This one. And the second, not any way, but along only y equal to 0, which means that this is x-axis. So you should have x tend to 0 on this x-axis. If the limit exists, now let me see. X, y tending to 0, 0 on x-axis. That is y equal to 0. So y equal to 0. In this case, you may eliminate this because y is 0. And in this case, you have 1. And limit xy tend to 0, 0, but y is already 0. Then you get only x tend to 0 to work on, and it is 1. So that is, now you can say that for this function, x squared minus y squared over x squared plus y squared, limit as x, y tend to the origin of coordinate along the x-axis exists and is equal to 1. 1 to 1. Right? That the thing you should pay attention on. Okay? Limit along a path. So here, remember, we already talked about the fact that if the limit of a function of two variables exists, then it is unique. Then it is unique, which means the limit, if exists, is only one value, cannot be more than one value. So because of that, we can think, if we let x, if we let x, y to tend to AB in two different paths, say C1 and C2, which means you consider the limit along xy tending to AB, xy belong to C1, and it is L1. Suppose you can compute it. Also, you can compute f xy, xy tend to AB, but xy is along C2, and this is L2. Right? Now you see, our purpose is to determine whether this limit AB, xy tend to AB exists or not. That's the question, right? And suppose you have two different paths, C1 and C2. And if you pay attention, if limit exists, one exists, then you can see that L1 and L2 must be equal. Because if exists, then the value of limit is unique. And exists here means that xy tend to AB in any possible way, right? We already talked about. In particular, along path 1 or along path 2, and they should be the same. This is one direction. But if you have different path and different limit, then we can say that if from here, then you can say that limit doesn't exist. General limit doesn't exist. But because if general limit exists, then L1 and L2 must be equal. Anyway, you should have the same value, right? But if you have two different paths along which you get two different limits, then gone. Limit doesn't exist, right? Okay, here, very important corollary. Suppose you have two different paths, C1 and C2, passing through a point AB. and the limit along these two paths are different. As AB tend to XY tend to AB, then the limit in general doesn't exist. So that corollary summarize what I explained to you. So then, if you want to prove that the limit doesn't exist, using definition very difficult, then you may think about the limit along path situation to solve this equation. So, for example, now you see, does the limit exist? And I want to show that no. I want to show that no. For which I need two paths passing the origin, along which you have different limit. The easiest path we can take is, for example, x equal to 0. So this one, on this, y equal to 0, sorry, y equal to 0. This is x-axis, the x-axis. Sorry. X-axis, I should write. So here should be x-axis, okay? The x, oh my God, no, x-axis, which means y equal to 0. In this case, fxy is 2x squared minus 0 squared over x squared plus 0 squared, which is 2x squared over x squared is 2. Along this path, C1, value always 2, then the limit of f xy, so this point xy tending to 0 and belong to C1. This is 2, right? And the other path you can take is here. X is 0, which means that the y-axis, this is C2. Again, you have fxy in this case is x is 0, 2, 0 square minus y square over 0 square plus y square, which is negative y square over y square is negative 1. So, which means if I have here C2, I write 2 here. That for economize the space I write. I don't want to erase. And I get negative 1. They are different. That is, there are two paths different passing the origin along which the limit of a function f x y is known, are different. Then you have non-existent. But the question is, why in the solution I consider x-axis and a bisector? A bisector of the first and the third quadrant. Tức là x bằng y là cái đường phân giác của góc phần tư thứ nhất và góc phần tư thứ ba. Đấy, cũng đi qua điểm góc tọa độ này. Đó. Y cái này thì chúng ta xét rồi này, giá trị của nó bằng 2 này. Cái này tại sao tôi lại đưa vào cái này trong cái solution? Because in many cases or in many problems, when you consider the x-axis and you consider the y-axis, they give the same result. They give the same result, which means it gives you nothing. Two paths have the same result doesn't mean that any path have the same result. Only two, right? So in this case, you should eliminate, for example, this path and take the other path. So C1, C2, you cannot have C2, then you take C3. Usually C3 is either y equal to x, the bisector of the first and the third quadrant, or for example, this one, y equal to negative x, quadrant 2 and quadrant 4. And you consider this one. And if L1 and L3 are different, then you get the answer. If the same result, you should think to take other path. Okay, that, and here illustration, along y equal to 0 you get 2. I already explained. But along the bisector, you have here, you change y equal to x, you have 1 over 2, and the result also 1 over 2. So they are different. Then we can conclude that the limit doesn't exist. Okay, so it's very interesting and important corollary on how to prove that the limit doesn't exist. And the question I already talked about, but here I want to remind you again. What happens if you take two paths, but the result is the same? Can we conclude that limit exists? No, right? The answer is no. The answer is no. Because not enough. You need any path passing AB along which limit gives the same answer. But here we have only two, right? But to answer that it is no, you should provide a count example. This is, I give it to you. You should do by yourself, which means that you have to provide some function fxy. And you provide two paths C1 and C2 such that limit of f when approaching to AB xy on C1 and limit of f when xy tend to AB on C2 are different. So this is the so-called count example. Okay, so do it home to understand. Oh, sorry, equal. They are equal. They are equal. That, okay, they are equal. But limit doesn't exist. Right? We cannot say that limit exists, but limit fxy, xy tend to AB doesn't exist. So this is what you have to do. Okay, so that's all for today. So we already study the first lecture number 1 and 2, the first two part of chapter 1. Lecture number 2, 3 plus 4 next week, and the last, the 5 and 6. So then we done lecture chapter 1 for 3 weeks. Chapter 2 for 3 weeks. Again, you have 6 weeks, the first part. And the other 6 weeks, you have differential equation. Okay? It's done for today. Do you want to ask something? Any question? Any question you want to ask? No? If you don't have any question, then you are free. You are free. Okay?
Right, teacher.
Yeah, see you next week.
I'm sorry, but is the end term of calculus 1 is multiple choice question or
Yes,
the
I will be announcing today or tomorrow to own not only your course, because you have only 450 students, still 200 students not taking this calculus 2. I will be announcing maybe tonight. I think the general department of General Education University already announced, but today, this morning I asked, no one announced about the format of the exam. So I will be announcing. There will be this, it will be the multiple choice question, MCQ, on the paper. You have a paper and you circle it as for your high school exam. Okay? Any question?
How many questions?
Oh, how can I answer you? 100 or 1,000? It depends. You will see on Saturday. How many questions, which part, etc. cannot answer. The only answer is 30% for part for the first 3 chapters and 70% for the last 4 chapters. I already announced, right? Okay. Any question? No? So see you next week, but not Saturday. Saturday you have invigilation. Bye-bye.
Bye, teacher.
Yeah, bye-bye.
Goodbye, teacher. Bye, teacher.
Bye-bye, bye-bye. Revise well.
Teacher.